So we're going to talk about light and some characteristics of light in terms of electromagnetic waves, and then look at some polarization of light. So first, light carries energy. It's a type of wave, and waves carry energy, not matter. So light carries energy. You can definitely feel this energy as the heat you feel from the sunlight. Light also travels very fast and very far. Stars in the sky are multiple light years away, which is millions and millions and millions of light years, or millions and millions of miles away. Also travels very fast. It goes 300 million meters per second. Extremely quick. Light will always travel in straight lines, but it can be bent by lenses or reflected by mirrors. This was in our last packet. The other way you know that light travels in straight lines is if you look up at the sky, and whenever a ray of sunlight comes through the cloud, it always is formed into a straight line. You never see a bend or curve in it. So what are light waves? They are transverse waves, which means they have crests and troughs. So they are perpendicular to the direction of motion. So here's our direction of motion, and you see crests and troughs, crests and troughs. And then you also have your electric field, which goes crest, trough, crest, trough. So perpendicular. They are also electromagnetic waves, which just means you have oscillating electric and magnetic fields, which is in this picture here. You have your magnetic and your electric, which are perpendicular to each other. Electromagnetic waves can also travel without a medium, so it can travel through a vacuum, especially a vacuum of space. This is really good because if light didn't, then we wouldn't be able to get any sunlight from the sun. So here is the electromagnetic spectrum, and a spectrum is just an arrangement of waves based on their frequency. So frequency, energy, and wavelength, which are all interrelated. So we see over here the longest waves are radio waves. So radio waves are light waves, not sound waves. And I know I talked to a lot of people about that whenever we did the sound demo. And then we have all the way over on this side very high frequency. So high frequency, high energy. We have gamma rays. These are extremely dangerous. These are the radiation energy that can affect your body and then, cause a lot of cancers and things like that. But it can also be used for a lot of really good medical uses. So we'll see that in just a second. So left of the visible, so visible is right here, very small section. Left of the visible, which is here below, is very low energy, very low frequency, and very long wavelength. So energy and frequency are directly related, and then they are inversely related to wavelength. To the right of the visible, over here with our X-rays and gamma rays, you have very high energy, high frequency, and short wavelength. So again, energy and frequency are directly related. Wavelength is inversely related. So let's just go through the spectrum itself. We're going to start with radio waves. These are used to transmit radio and TV. Now, this was the old style. TV doesn't go by electromagnetic waves anymore. It's all digital. But radio has FM and AM. So this is frequency modulation and amplitude modulation. The amplitude waves are much longer, which is why you can sometimes get AM stations that are in the Carolinas in Atlanta. Whereas if an FM station is over in Athens, sometimes it's really hard for us to get it. So these are shorter. The next set of electromagnetic waves, which are slightly shorter, so you can see the wavelength here. So microwaves are shorter. These are used in microwave ovens, and so what happens is the waves match the natural frequency of fats, waters, and proteins. And we know from resonance that whenever you match the natural frequency, it causes an increase in vibration. The vibration increases kinetic energy. More kinetic energy, higher temperature. It gets warm. This is why there are a lot of debates about whether or not cell phones are actually extremely dangerous for you, because cell phones work off of specific microwave frequencies. And so the idea is it close enough to our body's natural frequency to give us cancer? And there is still lots of debate. I can't give you one way or the other. So next we're going to look at infrared. visible, and ultraviolet. So infrared waves are what we call heat waves. This is what we release. So you know how we feel warm. This is what night vision goggles work for. Whenever you have night vision goggles on, you can see animals and people in terms of forms. It's because they're looking at the infrared radiation that we're giving off. Now, let's go back and look at our prefix here. Infra. Should remember infrasonic. Infrasonic was frequencies below human hearing, so below the sonic range. So infrared means below red waves. So these are frequencies below red. The visible spectrum, this is what we can see. Visible is what we see, and we only see 0.1% of the spectrum. So when you're looking from radio waves all the way through gamma, we can only visibly see 0.1%. Pretty crazy if you ask me. So we have 400 to 700, and if you look here at our range for human, 700 is your reds, so the longest wavelength is red, shortest wavelength is purple, or the violet, which also means that our purple or violet is our highest frequency, so highest energy. This is why those the bluer headlights that a lot of cars have can be so painful to the eye, is because when we're looking at them, they're much higher energy, and so there's more light that's really going into our eye. Whereas if you work with photography, or in a lot of cars, they also have that red dash. The red is the lowest frequency of visible, so it's also the lowest energy. So the last one we're going to talk about on this slide is ultraviolet. So ultraviolet is frequencies above violet. Ultrasonic above human hearing, above sonic. So ultraviolet is above violet. So these are higher frequencies than violet. This is why it can cause sunburn, skin cancers, cataracts, things like that. Why you have to wear sunscreen is because these are very high frequency, high energy waves. And when those waves hit your skin, it can cause serious problems. Now, another really neat thing is that bees can actually see into the ultraviolet. And so if you take an ultraviolet filter and take a picture of a flower, you'll actually see that it's extremely bright, especially ones that bees are supposed to pollinate. And it's because they're attracting the bees by making it very vivid in the ultraviolet. So the last two that we're going to talk about are X-rays and gamma rays. So this is the far end of the spectrum, highest energy, highest frequency. X-rays used for a lot of good uses. Medical applications. Whenever you go to the dentist once a year, you get X-rays of your teeth. If you have a broken bone, you get X-rays done of your legs or arms or whatever you break. Also used for airports. So whenever you go through security, you go through an X-ray scanner. Now, these can be extremely dangerous. In small doses, they're totally fine. So don't think you're going to get cancer from going to the dentist. But the reason why the hygienist leaves every time is because that hygienist is exposed to those X-rays for every single patient they see every single day. And so that can actually add up and be a medical issue for those hygienists. The highest energy is your gamma rays. So these are the smallest wavelength, highest energy. These are created by nuclear reactions, which we'll talk more about in our very last unit of the year. Yay! Also used a lot in medicine. Gamma rays are used to kill cancer cells, and mainly by these gamma rays will kill any cell that it touches. So if it's a good cell, it'll kill it. If it's a cancer cell, it'll kill it. So if you focus these rays, you can actually kill the cancer cells with this thin beam of gamma rays. This is what we call radiation treatment.